Hello, I'm Summer Farrow, Applications Engineer, and with me is Rob Pinelli, Senior Software Engineer. And today we're excited to provide you with an update on Teledyne Benthos' ropeless fishing technology, specifically on acoustic triggering, positioning, and communication. Our efforts align with the evolving landscape of on-demand fishing gear, and we're delighted to share our progress with you. For over 6 decades, Teledyne Benthos has been at the forefront of oceanographic equipment development. Our headquarters are located on Cape Cod in Massachusetts. Presently, we're working in close partnership with industry leaders such as Smelts, Lift Labs, Canadian Wildlife Federation, the State of Maine's Department of Marine Fisheries, and Raymarine to advance ropeless solutions that empower sustainable fishing practices.
Our focus has been on using our acoustic modem to not only enhance capabilities, but also meet the ever-evolving demands for gear marking information in cloud-based systems, for the prevention of gear overlap, and for regulatory visibility. Each transmitted message, which lasts just a second or two, can contain commands or status updates such as battery voltage and trap orientation. We've chosen to operate in a band above 20 kilohertz frequency. This choice simplifies regulatory considerations and helps restrict the acoustic propagation range to under 2 miles while remaining clear of much of the boat-generated noise in the water column. This in turn minimizes acoustic noise in crowded fishing zones, thus supporting the effective use of ropeless gear. We've transitioned ropeless applications to our ultra-compact modem, or UCM, featuring a smaller board footprint when compared to our standard acoustic telemetry modem. The UCM can be produced in higher volumes and at reduced cost. It features specialized ropeless firmware, a hibernation mode, variable length inflation signals, battery life updates, trap orientation measurements, and optional depth and temperature sensing. A lessons learned moment was found by Smelts with our low-power 32 kilohertz oscillator on the UCM. Off-gassing of hydrogen molecules from sealed lead-acid batteries affected our new MEMS crystal oscillator, causing the traps to cycle power and consume more energy than expected. We devised a stopgap solution for this with a programmable logic device change to use a different onboard oscillator while we identify a permanent solution.
We've also introduced the Directional Acoustic Transponder, or DAT, which leverages ultra-short baseline technology. Coupled with GPS, the DAT can pinpoint the bearing, range, and accurate position of a trap on the seafloor. This technology's potential was showcased on the fishing vessel Resolve, where a standard DAT transducer was hull-mounted, providing a real-world use case. We have done thorough performance tests using the gear on the fishing vessel Resolve and have gathered a lot of information on how we can improve the performance of the gear on the vessel. Of note is the importance of proper gear installation. During our testing, we noticed an inverter for the laptop we discovered as the culprit, injecting electrical noise into our battery, reducing receive performance by 30 dB. As a result, our range performance was reduced to a few hundred meters. Additionally, echo sounders on the vessel contributed to reduced performance. Knowing how to identify and remedy these issues are vital for technology to perform at its best. We have been focusing on the mechanics of tracking the first ropeless trap in a trawl as it leaves the lobster boat. There is limited time to wake up and ping the trap as it falls to the seafloor, so refining the surface GPS position captured when entering the water is paramount. Time is critical, and a simplified interface and process is necessary.
Users of our gear have often selected our Universal Topside, or UTS, as their topside communication platform. Work on this platform to add ropeless features includes definition of a lift bag fill time, as well as a database of fisher information, gear assets, and deployment statuses. Our next project is to add an Ethernet interface to a cell modem in order to send current trap data to the cloud. A panel-mounted UTS may be a desirable choice for lobster boat installation. Our journey continues with promising developments, including improved PC-based Track-It ropeless fishing software, which boasts a new layout centered around the fishing chart, and a streamlined transducer design suited for various fishing vessel hulls. Collaborating with Smelts, we've integrated a pressure sensor capable of determining trap depth and water temperature, critical data for scientific research and fishers alike, as well as being useful for automating the lift bag inflation process.
Looking ahead, we envision combining the abilities of the DAT with Raymarine's expertise to create a fully integrated chart plotter system. The innovation will allow fishers to navigate, mark waypoints, and deploy, locate, and retrieve on-demand gear efficiently through a built-in multifunction display. In conclusion, Teledyne Benthos is committed to advancing on-demand fishing technology through acoustic solutions. Our goal is to make this technology accessible, user-friendly, and seamlessly integrated within the fishing industry, promoting sustainable practices for our ocean's future. Thank you for your time and being part of this exciting new frontier.